Hi, this video is going to cover solving proportions. So the learning goals for this video are to learn various strategies to solve the unknown value in a proportion and also to model and solve problems using proportions. So this is an example of a proportion that we would need to solve because we have two ratios here that are equal to each other, but there is an unknown. So we're going to come up with three ways of solving that problem. So we can use proportions to solve problems that involve a directly proportional relationship. So here's an example. A recipe calls for 2 tablespoons of chocolate for every 3 tablespoons of banana. So let's say if Mark, my friend Mark, intends on using 12 tablespoons of banana, how much chocolate should he add to his recipe? Well, let's start by using a diagram. Okay, so we have a ratio of 2 chocolate for 3 banana. So if we add 3 more tablespoons of banana, that means we would have to add 2 more tablespoons of chocolate. Right? If I add another 3, I have to add another 2 chocolate. If I again add another 3 bananas, I would have to add another 2 tablespoons of chocolate. So all of a sudden now we have 12 tablespoons of bananas, and look what we've ended up with here. We have 8 tablespoons of banana. So just by looking at this picture, okay, and growing with it together, bananas and chocolate, I notice that I need 8 tablespoons of chocolate. So that is using a pictorial representation to solve this problem, but we can use other more, formal methods of math here. One is using a proportion and the constant of proportionality. So here is a ratio that we know, okay, 2 tablespoons of chocolate for 3 tablespoons of banana. Now, the ratio that we don't know, right, is we have 12 tablespoons of banana, right? So the banana number is on the bottom. So I have to write 12 on the bottom of this one because that represents bananas, right? And I don't know how many tablespoons of chocolate I need, right? That's the question. Well, if we take a look here for a second, to go from one ratio to the other, which is equivalent, right? To go from 3 on the bottom here, I have to multiply with some number to get to 12. Well, 3 times 4 gets me 12. Right? So that means to get from 2 to this unknown number, well, I have to multiply by 4 as well. So 2 times 4 is, of course, 8. So this unknown value of x is 8. Right? So again, that's 8 tablespoons of chocolate. So to determine the constant of proportionality, okay, we do so using multiplication or division, and then we use it to find the unknown. So again, 3 had to multiply with 4 to get to 12, so that means 2 has to multiply with 4 to get you the answer, which would be 8. Now the third method is solving a proportion algebraically. So again, we're going to start with a ratio that we know, 2 chocolate for 3 tablespoons of banana. Again, that's equal to x over 12. So this is an equation where two ratios are equal to each other. Now, both sides of this equation have to stay equal and have to stay balanced. It's kind of like a seesaw. So if I'm going to mess around with one side of the equation, I have to mess around with the other side exactly the same way. Now, I want eventually an answer where it says x equals some number. That'll tell me what the answer is. So I got to somehow get rid of this divided by 12 part. And to get rid of this divided by 12 portion, okay, I just have to undo it, okay, which means doing the opposite of dividing by 12, which in this case means you multiply by 12, since multiplying and dividing are what we call inverse operations, or the opposite thing. So 12 here, if I multiply this side with 12, that means I'm going to multiply the other side by 12 as well. And the whole point of doing this is 12 divided by 12 gives me 1. So I have 1x left on this side. And on the other side here, we have 12 times 2, and then we divide by 3. So 12 times 2 is 24, and then 24 divided by 3 is 8. So again, we get the same answer 3 different ways. Okay? But in this case here, we solved it algebraically by multiplying both sides by the denominator. Okay, so in other words here, let's write that down. Whoops, that's the wrong letter. Okay, we multiply both sides of the equation by the denominator, okay, under x. All right. Let's do a few more examples here. We're going to flip-flop between the two more formal methods because the picture method is it can be very time-consuming, and especially with large numbers, it would be a problem. So let's just stick with the formal methods for now. We'll come back to the picture later. So let's do the constant of proportionality method to solve for x for part A. So 5, how do I go from 5 to 20? Well, I'm going to have to multiply by 4. So that means if 5 times 4 gets me 20, that means 3 times 4 has to get me the correct answer for x. So 3 times 4 is 12. So x has to be 12. Let's look at the second example here. Now, x is in the denominator here, but I'm going to try using this, doing this question using the algebraic method. So here, if we go back for a second, we multiply both sides by the denominator under x. So that means x has to be on top in order for this method to work. But x is on the bottom here. So I've got to figure a way to put x on the top somehow. Well, if you can imagine, we can flip this upside down. I'm allowed to do that as long as I flip the other side upside down. So I'm going to do that as well. All right, that's perfectly within the rules. Okay. So now x is on the top, so I can do that method of multiplying by the denominator under x, both sides. Okay. Now, again, the whole point of that is 3 divided by 3 makes 1. So x here is equal to, and then I do 3 times 20 divided by 8. Right? So let's just do that. Let's move it over. 3 times 20 divided by 18. There we go. 3.33. Okay. Now, if you don't like that decimal number, okay, we can reduce this fraction. So x is equal to, and then to multiply a whole number with a fraction, we just multiply the whole number with the numerator. So 3 times 20 is 60. So we can write 60 over 18. But if we reduce that by dividing the numerator and the denominator by 6, that means that's 10 over 3. Okay? So both are fine. Okay, this is more formal, but this could be acceptable as well. Let's look at the third example here. We can do it either way. We can do it both ways. So let's think about this for a second. I need to multiply what with 4 to get to 30? Well, that's kind of tough. So in order to figure out what that number is, let's go backwards using division. Okay, and we can figure out what that multiplicative number would be. So 30, if we divide it by 4, gets me 7.5. Now let's go backwards. 7.5 then would multiply with 4 to get to 30. So to go from 4 to 30, we multiply by 7.5. So that means to get the answer here, I have to multiply 9 with 7.5, right? And 9 times 7.5 would get me 67.5. Right? Now, we can do this using the algebraic method by, again, we flip both sides, okay, upside down. That way x is on the top. And then we would multiply both sides by the 30. Okay, so the 30s will divide out. Oops. So x is equal to, and then we would do 30 times 9 divided by 4, which gets us 67.5 again. So it doesn't matter how you do it, right? Either way works. So here are the success criteria. We can either do this using pictures. Okay? We can do it using a constant of proportionality by writing a proportion first and then determining the constant by using division or multiplication. Or we can do it algebraically by, again, first writing a proportion and then ensure that the unknown is in the numerator. So make sure you can flip it, okay, flip both sides, and then multiply both sides by the denominator of the unknown ratio. So here are 3 examples. I'd like you to try them out. Use any method you wish. Pause the video, give them a shot, and when you're ready to check your work, press play. Good luck. Okay. Let's just I don't know. I'll just randomly pick an option here. I'm going to multiply. I'm going to do the algebraic method for this one. If you did it the other way, no worries. Hopefully you'll still get the right answer. So you multiply both sides by the denominator under x. So the 200s will divide out. So x is equal to 200 times 2 divided, times 2 divided by 5, which is 80. Okay? So that's one way. Here, let's do the constant of proportionality. So how do I go from 50 to 8? Right? Well, I'm not sure. So let's just go backwards here. Okay. So 8 divided by 50 gets me 0.16. So that means I have to multiply 50 times 0.16. Now if I go the other way, so 24, that means I have to multiply with 0.16. So what would that be? 24 times 0.16, 3.84. Okay, so that means x has to be 3.84. Okay. Here, let's switch it up and let's go back to the algebraic method. So I notice that x is in the denominator, so I have to flip this fraction, and I have to flip the other one. And then I multiply both sides by the denominator there, which is 102. So x is equal, and then I figure out what that is, 102 times 5 divided by 6. So that's 85. Right? So hopefully you got the right answer, and it shouldn't matter which option or which method you choose. Okay, so here's a question about nurses and patients. So a nurse to patient ratio of 4 to 10 ensures patient safety. If 10 nurses are working, how many patients can be admitted? Use 3 ways if you want. Okay, let's solve the problem. Give it a shot. Best of luck. Pause the video. All right, let's use the diagram here first. So let's just double it up. If we put 4 more nurses in, so that means we've got 8 nurses. So if we double up the nurses, that means we can double up the patients. Oh, whoops. So, but now I only want 2 more because there's 10 nurses. So I'm just going to take half of the nurses in that group. So if I take half the nurses in that group, that means I can only take half. Whoops. Sorry. That means you have to take half the patients here. All right. So if we add them up, 5, 10, 15, 20, 25, we can say 25 patients. All right. Now, let's do this using an algebraic method. So we start by writing a proportion. We start with the ratio that we know, which is 4 to 10. We make it equal to a ratio we don't know. So 10 nurses. So we got to put the 10 somewhere, either on the top or on the bottom. But I noticed that from the original ratio that the nurse number is the first number. So I have to put the nurse number of 10 on the top and some number on the bottom. I don't know what it is. So to do this algebraically, we're going to flip this upside down. So that's x over 10 is 10 over 4. And then I multiply both sides by that denominator there, which is 10. So x is then equal to 10 times 10 is 100 divided by 4. It's 25 patients. So again, same answer. Last way, let's write that proportion again. So I have to multiply 4 with something to get 10. But let's go backwards then to figure out what that is. So let's do 10 divided by 4 to get that constant, which is 2.5. So that means here I'm multiplying by 2.5. So that means to go the other way, I got to multiply with 2.5. So 10 times 2.5 is 25 again. So 3 different ways, same answer. So let's just sum it up. We can use proportions to help solve problems regarding proportional reasoning. We can solve problems by either using a constant of proportionality or by algebraic methods. The picture method's a little bit, it can be very time consuming drawing all those pictures. And to solve a proportional problem, you first create a proportion, which again, you create it by using a known ratio. Okay, known ratio, and then make it equal to an unknown ratio. Okay, and then once you have that, you solve it using any method you want. Okay, so hopefully that makes solving proportions and using them to solve problems clear. And thanks for watching, and best of luck.